everybody, welcome to the lesson on regression modeling. In this lesson we're going to be creating the equation to predict a dependent variable. And that's what a mathematical model is. In regression modeling, it's a regression equation. So regression is our method for coming up with what that equation is. So this section is a little bit different from some of the other sections that we've done in the course. There's always been a degree of subjectivity to our analyses, but in this section there's even more subjectivity. We're going to need to decide which variables to include in the model. We're going to need to decide whether to do transformations on those variables. And we're going to need to decide, whether outliers should be excluded or not. And for all of those decisions, we've got statistics to guide us. We've got, graphs and principles to consider. But in the end, some things are just subjective. And so you may very well have, 5 different statisticians who come up with 5 different models for the same data. And that's okay. That's just part of modeling. None of those models are considered to be perfect or exactly right. So we're just trying to come up with the best we can. And what we're looking for is an equation that's going to fit the data, that's going to be a good fit to the data. And we know that by looking at the R squared and the adjusted R squared. But we also want a nice parsimonious model. We want to have as simple a model as we can while still fitting the data. Okay, simpler models, and when we say simple, we mean with fewer variables and fewer transformations. Those are generally more generalizable to future situations. But sometimes it is necessary and important to do that. So even though there may be multiple models for a situation, ideally all of them fit the dependent variable in a way that makes sense. So we're actually going to look at maybe a couple of different models. In this lesson, I'm going to walk you through some of those principles. And then we're actually going to do the example live in class rather than on the video. And then I will, when we do the example live in class, you guys are going to take the lead in making those decisions. And we're going to see what you come up with. And we are going to compare it to what I came up with. So we'll see if yours is the same as mine or different. I'm going to walk you through the general process of creating a regression model. One thing to keep in mind as we go through this is that if you change one thing, it changes everything. If you take out one variable, the rest of the coefficients recalculate. And sometimes it changes whether a variable is statistically significant or not. The same thing happens when you do a transformation or take out an outlier. It changes everything. So there are a lot of different permutations of variables you could include and transformations you could do. You could get lost in the model building process and spend hours and hours doing it. I wouldn't recommend doing that because I've done it before, and I've learned that there's diminishing returns to trying more and more and more things. You get into models that are just not as parsimonious. So let's talk about the general modeling process, one step at a time. The first step is, and by the way, as we go through this, count the number of times we refer to the importance of of considering the context. That is absolutely key in building a model. Before you run your data analysis, and actually if you're part of the team or the person who's responsible for collecting data before that point, you should be familiar with the context of the data. So ideally, if you're doing some data collection in your major, you'd know what that process looks like that you're investigating. Ideally, also you've done some literature reviewing where you've looked to see what other studies have shown, and you can take that information into your model building process. Sometimes it's just an everyday context and you just have to use your own general intuition of things. And, when that's the case, it is the case. So that's sort of the pre-modeling process, is to get to know your data really well. The first real step is to look at all of the independent variables that you have available to you, and then choose the ones that you think are going to be good predictors. So you may have, hundreds of variables in your data set, but that doesn't mean you should throw them all into the model to see what sticks. You only want to start with the ones that make sense according to the context of the data. Next, we're going to do sort of just some initial diagnostics. So among the independent variables that you choose, we're going to look at the correlations, and if we've got any that are really high, we're going to, use the context and pull one of those out, because we don't want them if they're redundant. You're also going to look at scatter plots of each independent variable against the dependent variable. If you've got outliers, now's a good time to look into that and determine whether you should remove them or not. And also, if you see a nonlinear relationship, now's a good time to do a transformation. If you do a transformation, rerun that scatter plot and see if now it looks linear after you've done your transformation. And when I say your transformation, I mean what we talked about the other day with doing a calculation on your independent variable, like taking the square root of all of those, and then using that transformed variable in your scatter plot and in your analysis. There is one thing I want to show you how to do in SPSS at this point. I want to show you how to eliminate outliers. So if there's a data point or two, or however many, that you don't want to include in your analysis, say we wanted to exclude Uptown, okay, because Uptown has a really high property crime rate, and I'm not going to tell you whether I'm going to exclude it or not, because you're going to come up with that decision separately of me. But if we did want to, then the first thing we'd probably do is sort the data, just to help us find that. And we take our property crime rate and we'd sort it, and maybe sort it by descending. This doesn't matter. You're either going to look at the end of the data set or the beginning. So if we sorted it by descending, then our highest crime rates are going to be at the top. And you can see that's here. So 845.3, which is a lot higher than some of the other ones. So if we wanted to eliminate that one, we could. And this is under data, select cases. All right, so here under data, select cases, and we're going to pick a variable like property crime rate. Oops. Back to select cases. First I have to do if condition is satisfied. I'm going to reset this because I've been messing with this. So if condition is satisfied, click on if, and we've got property crime rate. So if property crime rate is greater than, or let me say less than, if property crime rate is less than 840. So if property crime rate is less than 840. This takes out the one that's 845.3 and says these are all the ones we're going to keep. Okay. And we're going to click continue, click OK, and then from here on out, this observation, and you can see it's X'd out here, is not going to be considered in the analysis. So if we run descriptive statistics on there, it won't include that observation. And that's going to be that way until you go back and change it by going to Data, select Cases, and then change that back to all cases. Okay, so you don't have to do that before every analysis. You just do it at the beginning and then change it back when you're finished excluding the outlier, if that's what you decide to do. All right, so that's the second step. Do an initial screen for problems. In step 3, you're going to figure out what your model is going to be. So you're going to start by, so this is based on what you've got up here. After you do any outliers that you want to remove, after you remove any variables that are redundant, and after you do any transformations based on what you've got here. If you've got variables that are not significant, don't remove all of them at one time. Just take one of them at a time out, remove one, and rerun it to see what happens. Because as I said, if you remove one variable, that changes the coefficients and sometimes even the statistical significance of the other variables. The decision of how to remove them in what order, you can start with the highest p-value, or according to the context, you might look at pulling out first which variables seem to be the least related according to the context. Okay. And you keep doing that, remove variables until you've got all of them statistically significant. If you don't have any variables left that are statistically significant, go back and look at your data and see if there are some other decisions you could make at this point. Sometimes the best model is no model. Sometimes the best decision is to say this data is not suitable for modeling, which is a disappointing result, but sometimes that's what you get. So once you look at your statistical significance, then you do those diagnostics on residuals, looking for homoscedasticity and outliers. lack of outliers. If you have any problems there, you might want to make transformations. If you make any transformations, you got to go back up here, run the model, see if that affects your statistical significance. And then check your residuals again if you make any changes up here. So you could really get stuck in a loop here. This is where you could try things over and over and over again. In terms of these assumptions of homoscedasticity and lack of outliers, do the best you can to satisfy these assumptions, but sometimes you just can't. Sometimes you can minimize it, but you have to go on, and you just, if you can't satisfy those, you just state that in your write-up. Or if you're writing a journal article, you would state that there, and you'd be careful then with your inferences. So we are going to go over this example in class. Like I said, I am going to create a model and bring that with me to class, and then I'm going to have you in class make these decisions, and we'll compare what we come up with. Now, once you've got your model and you're happy with it, you may want to generate some predictions based on the model. Now, we've already talked about how to do a prediction, but let me show you how to do it in SPSS. So here's an example. Suppose we want to predict the property crime rate for a neighborhood with these characteristics. Median income $60,000, population density is 4 people per square. I can't remember what that unit was, so we leave that as a blank. 30% of the neighborhood is youth population. 8% of the neighborhood gets nutrition assistance, and 94% of the neighborhood adults are employed. So here's what we're going to do. In SPSS, you're going to add a row, and in that row, you're going to type in those values of the independent variables that you want to predict. So I've typed these values in to a row down here. Only those values. You don't need any others. And in fact, you really, really need to leave the dependent variable blank. Okay, don't type anything in for your dependent variable. And then watch what happens when you run your regression. So I've already got this set up with our variables. We're going to click on Save. And then if you check Unstandardized, this is going to save the predicted values for every row of that data, including the one we just typed in. So click OK. And then we go back and look at our data set, and you'll see an additional variable here. This pre-1, these are all of our predicted values, including for the one we just generated. Okay, so this row of data didn't get included in creating the regression model. It's just there for prediction. All right, so our predicted value is a 20% property crime rate for this neighborhood. Now, there are many inferences you could make based on regression models. I'm going to look at 2 of them, though. One of them is a confidence interval for the mean value at a certain point. And this is going to tell us, this is going to give us a 95% confidence interval for what the mean prediction is at this combination of independent variables. Okay? So this is a confidence interval for the mean value at that prediction point. Then there's a a prediction interval that's for a new observation. So this is not for the mean at that point. This is for what one single new observation will be. So the prediction interval is going to be a whole lot wider than the confidence interval, because the confidence interval is for the mean, which is not going to have as much variability as a single observation. And these are in here under save as well. So under regression linear, under save, we already saved the predicted values, so I'm not going to do that again. It will, if you run it with this checked, it'll tack on another column of those predictions. It'll just be exactly the same. And this is going to give us our confidence interval for the mean value at a prediction point, and this is for an individual value at the prediction point. So click continue and click OK. And you see over here, it gives you some extra columns. This LMCI means the lower mean confidence interval, and this is the upper mean confidence interval. So according to this, we are 95% confident that the mean value, the mean property crime rate in a neighborhood described by these values that we had over here, you know, the 30 and the 4. We are 95% confident that the mean will be between 11.4 and 28.7%. Or it might be crimes per 1,000 residents. We'd have to check what those units are, but 95% confident that the mean at this point will be between these two values. And over here, these are the lower and upper individual confidence intervals. This tells us an interval, again, that we are, so here we are 95% confident that a new neighborhood at these independent variable values would be within this range. You may notice this is a huge range, so sometimes the prediction intervals, when they're that big, it's so wide that it's not really useful, but because we obviously can't have a negative crime rate. But this is what we got, and so that's it for this lesson. And you know, I've got the instructions here. Please let me know what questions you have. I am always happy to answer your questions. I'll look forward to seeing you in class.